So we can go ahead and get started.
Ready?
Ready.
Okay. Good morning, everyone. I am Barbie Little, and I'm with my colleagues Philip C. and David Hartley. We are West Virginia University Extension agents in the 4-H Youth Development Program. And we're going to share a little bit today about microbits, and they'll take over in just a minute guiding us through the microbit activities. But this was a project that I was able to get started for us because I was working with the West Virginia statewide after-school network in STEM, and I was part of the STEM Next grant. And through that, we were able to spend some money and get these microbits and some supplies that went with them to do some teaching. And we got this in 6 counties that have after-school programs or do outside of school learning time. And with that, we've been learning about microbits during this time because we got everything right before we shut down for the pandemic, and we've still been moving forward during this time with our project. So with that, I will turn it over. If you have questions along the way, if you'll use the chat, I will man the chat and we'll keep watching there. So you are welcome to comment in there, and we will give time for questions.
Today we're going to talk to you a little bit about what is a microbit. And so I'm going to hold a microbit up in front of my nice little camera. It's really hard to see. You can see it on the slide too. A microbit is a little board that has lots of different sensors associated with it. And so it was originally developed in the UK, and that's kind of where we've learned about it. And it is, think about a little processor. It's basically a small little processor that allows you to compute data. We're able to code with it. We're able to input stuff into it. It has sensors. Some of the sensors that this little microbit has is it has the ability to tell the temperature. It has the ability to measure how fast you're going. It has an internal compass. It has the ability to connect Bluetooth to another microbit. And so it has Bluetooth ability to talk to one another. It's got some buttons on the front. If you can see, I've got a heart-shaped LED lit up, and so those 25 little dots you see on the front are actually LEDs, and you can scroll text and you can put images on it. And so how do we use the microbit to teach? What we're really doing is this is going to be an intro level for introduction of how we're trying to teach some basic coding. Start with block-based coding and then expand to some other areas. We use what's called make code to do a lot of it, but it has the ability to download the code and what forth. Why we decided this, it's a real, the cost is really inexpensive for us to be able to use and purchase for the amount of technology that's available. And so that's something that was a really important part. And when we start thinking about some of the features, it does have the ability to be very user-friendly. It's very small and simple to use. It can be attached to a battery pack. You can connect it to your computer and power it and download programs. It's very diverse on which type of systems that you can be used on. It can be used with a computer. It can be used with different types of devices, whether it's iPads or tablets or different types, and it works very well with that. And so we'll get into some of how this works and some of how the microbit works and how we can use some of these sensors and start to program a little bit later. But that's just kind of an overview of the microbit.
So this is kind of leading up. Barbie's going to talk about kind of an overall budget and the overall costs of the microbit and the other technology needs that you would have. But you are going to need a device to run the microbit. So the good news is whatever devices you may already have will very likely run them. So if you by this time, you probably with your program, you probably have maybe some laptops, maybe a set of iPads, a set of Android tablets, whatever you have. The good news is that you will probably, or you may very well already have that. If you don't, as David mentioned, they do have Bluetooth. The microbits have Bluetooth, so you can connect and run them with more or less any type of tablet. So iPads, Android devices. We've had mixed results with the Amazon Fire tablets, so which is a little disappointing because the Fire tablets essentially are an Android device, and they're much cheaper than just about any other tablet you can find. But the problem is they don't have the Google Play Store on them to download the app, so you have to find a way to get the Google Play Store downloaded and installed on the tablet, and then download the app to run them. So I would be cautious about getting Kindle Fire tablets, Amazon Fire tablets. Again, we've had mixed results with those. That's not to say you can't make them work, but they are a little bit more difficult. You can also use them just with a computer or a laptop. So that's my preferred way to use them. When I use them in schools, I do not as much after school, but in school, during school enrichment programming. You can connect them through a USB. So there's a micro USB port, which actually on this slide up at the top is a picture of the back of the microbit. So the last slide was the front of the microbit. This slide is the back of the microbit. And I believe number 6 up at the top here is where you have the USB connection. So you can connect them through a USB and use Microsoft MakeCode, which we're going to show an example of a little bit later on, and actually you will get to test out. You can use MakeCode, or you can use them with a tablet and use the microbit app, or you can use them with a smartphone as well. So in general, we have found that Apple products with the app are a little bit more friendly. It's not to say you can't do it with Android. So if you have Android tablets, don't think, oh no, I have to go out and buy a bunch of iPads. That's not the case. They definitely work with Android. It's just we found it's a little simpler with the Apple tablets. And me personally, I like the computers if you have access to the computers. It depends a little bit on what you're trying to do too. You could actually program these microbits to sit and run for a long time. So if you're doing that, you may want to have some sort of tablet. You may not be able to devote a computer to it or devote your phone to it, although you can certainly use your phone to program it. If you're doing basic coding, the tablets are definitely okay. If you're going to get a little bit more advanced, a computer may be easier, but I'm still one that likes to work from a computer. I have an iPad, but I would still rather work from a computer. And when I'm doing the more advanced things, I prefer to do a computer. But you are going to need a device. But again, as I mentioned up front, there's a good chance that you may already have the device that would be compatible.
So when we were looking at this project, I reached out to a lot of qualified tech people to get information. What was a rather inexpensive way that we could start something? And this was a great project to begin with. So to give you just an idea of a startup cost, there's the Microbit Club Kit, which it's a 10-pack, and they are $159 each. The servo motors, which David and Philip will cover more about what each piece is as we go through. A set of those were $17.59. The 37 sensor starter kit for microbits, $55. Alligator clips. If you are doing coding, you know that these alligator clips, we all have them in large amounts, hopefully, because we're needed all the time. Found a good deal with those for $9.86 for a bundle of those. And then if you are getting the microbits out to the youth or letting them get them in their hands, those were the protector cases for those were $5.92 a piece. We did not put in the budget a a device to use it on. Again, like Philip said, we found with the newer Kindle Fires, they were not as friendly with the app. You could do everything on there, and then it was a need to reload. The older Kindle Fires, if you have those in your program, those worked really well and were very smooth and consistent. So we found the Apple tablet or using a computer was the better way to go. So we did not include that in the startup cost. Hopefully, most programs, if you're doing any kind of coding, have something that you're already using, and this just picks right up with that. But this was a good startup cost and for what we got into it with. And like I said, I was able to get this and put it into 6 different counties so that we would be able to loan them out and do teaching with.
So as far as what we're going to be showing you today and the activities that we've built, really you only need number 1, which is the bundle of 10. If the bundle of 10 puts them at about $16 a piece, as you can see there by the price. Individually, they're probably a couple dollars more a piece. I mean, if you're wanting to buy some of these individually, if you only want 3 of them, you're still probably only looking at $20 or less for sure. You know, $17, $18 is probably what you're looking at if you buy them individually. And then it is a good idea to get a case. You don't have to. The cases we got are very good. It's kind of a hard, almost plexiglass type thing. The 2, 3, and 4 in there, the servo motors, the 37 sensor starter kit, which has a lot of really neat other sensors and it's got projects that go along with it. So you can build alarms and you can build, it's got sensors that'll detect, you know, different level. There's one that senses alcohol. So if you've got it's almost like a breathalyzer. You can put a project you can put together. There's just a lot of different sensors that are in there. So if you're wanting to go deeper than some of those sensors, again, really good deal. That 37 sensor starter kit will get you a lot of different projects. And then, you know, alligator clips, things like that are good to have on hand. And it's a good idea to get, you know, a case. We got cases from Harbor Freight. I don't know if you've got a Harbor Freight nearby where you are, but, you know, any sort of Walmart, a tackle box, fishing tackle box, things like that to get cases to put the whole thing in and all your accessories. So really very inexpensive to get started if you're looking at, you know, $16 each for a 10 pack. So depending on the size of your you know, program, whether you want everybody to do, usually you can work in pairs with these. So a 10 pack would pretty easily serve about 20 people. So so if you're looking we want the microbits to get started, you're looking at you know, kind of number 1 there, and probably a good idea to go ahead and get number 5. So the next thing to talk about is some activities that we've developed. So it's been kind of an interesting journey for us, as I know it has been for everyone over the last 6 months or so, since the middle of March when the pandemic hit and everything shut down. So we've had a lot of change in plans since then. We've had a pretty significant change in plans since we initially submitted to teach this session. So we've kind of changed and adapted, and we think we've got something that kind of fits the current guidelines and the current you know, situation that we find ourselves in with the pandemic. I'm sure many of you may still be doing activities virtually, and we have activities that will fit that. So we'll kind of explain and go a little more in depth in that. I'm going to talk about the activities that we have developed, and then David is actually going to lead you all through a couple of the activities that we developed. So you're actually going to get a chance to try it out on your computers. So the way this all started was we had a group of agents. So, you know, Barbie and David and I are all county-based extension agents, 4-H extension agents in West Virginia. We had 3 more of those agents that were involved with this microbit project and wanting to kind of learn this and deliver these programs to youth in their counties through their 4-H programs, through after-school programs, however they. And you know, David has had the most experience with microbits. I've had a little bit. Barbie had essentially none before this all started, and Barbie can attest that you know, she learned this from scratch, from no previous experience. She learned how to do the to program the microbits, to create an activity, and then now to turn around and be able to deliver those programs to you. She learned that with basically no experience whatsoever. So don't think, oh, I have no idea how to code. Oh, I don't know how to do this. These activities are very entry level. They're ones that you should be able to pull up the activity sheet and learn them yourself, go through it and learn it yourself. And then we'll talk a little bit too about how we've adapted this virtually and kind of what's still to come with these. So we developed these activities that are very much beginner level, and you'll see when you walk through this activity yourself, it's very beginner level. There's no prior experience needed, and it's a very good introduction to computer science. So if someone's never heard of coding, they don't know what programming is, they don't know computer science, they've never done any of that, this is a very good way to start because you don't need a lot of prior knowledge. However, the microbit can get very, very detailed. So I don't know if I would say it's advanced coding, but you can go pretty in depth. It starts with what's called block-based coding. So that's some of what you'll be doing today, where basically you just drag blocks over and connect them. So it's very similar if any of y'all have experience with Scratch, or there's a bunch of Tinker, there's a bunch of apps that use block-based coding. So you have kind of pre-coded blocks that you drag over and connect, and they make whatever code that you're wanting to do to program the microbit. So it starts with that. Actually will progress into with the capabilities. You don't have to go there, but actually progress into text-based coding. And text-based coding is kind of your, you know, what your programming languages are going to be. So it actually will use Java and Python, which are 2 of the programming languages in the world to make apps, do pretty much anything on a computer. You use those programming languages. So this could be a very good, and that's where, you know, I had done a lot of programs with Scratch and kind of the block-based coding, and that's where, you know, I kind of microbits is the possibility to transition to text-based coding. So you can use it as very basic and beginner, and then you can use it as kind of the intermediate and kind of that bridge to text-based coding. So our activities, we've created 7 activities. One of them's a very, very basic introductory activity. We go over the kind of an introduction, then we talk about the buttons. You learn how to scroll text across the microbit, which that's what you are going to try today, to program the buttons and to be able to scroll text. We have one using the accelerometer, which is a shaking activity. So you actually program the microbits to be able to play rock, paper, scissors. There's one using the temperature sensor. There's one using a light sensor. And then the final one is an introduction to text-based coding. So where we're at, kind of our timeline, everything kind of shifted. We were very much looking at doing in-person activities and learning how to do in-person activities to be able to deliver those to youth in person. And the activities that we have, you very much still can do that. But we had to shift, and now we're looking at something to be done virtually. So that's kind of changed our timeline. So our activities, we have we're going to give you a link to a Google Docs folder. We have 5 of these in there. 2 of them still need just a little bit of tweaking, and those should be in there by the end of the week. And then we're also we're in the process of creating kind of instructional walkthrough videos for these. So we're going to have the videos that walk the kids kind of through, or if the facilitator, if you're wanting to either play the videos for the kids or watch the videos yourself to learn and then teach the program yourself, we have those activities, or we'll have those are not finished yet. The format could change, so we plan to host this material in that Google Docs folder for you. For you whenever you want to access it, but just know that some things may change. So here, within about a week to 10 days, we're going to start, we have through the WVU Extension Service, through our 4-H program unit, we have an review process. So this is going to be reviewed by some of our internal people that have a lot of experience in STEM and have worked a lot with these programs. So they're going to be peer reviewed. So they're there now for you to use if you want to go ahead and use them. Just know that at some point when you access them, they may change slightly. I don't think the core content will change. They'll change a little bit, and they may be tweaked slightly. And then the main thing you'll see probably eventually will be some branding. So right now, they're just kind of the base activity sheets. Once they've been through the internal peer review process and everything's good to go, they will be branded with the WVU Extension Service and the 4-H Clover and those types of things. So they're there. They're there for you to go ahead and use now. We'll be adding the videos. Our ultimate goal is to have this hosted somewhere that the kids could just go on and complete it themselves. So that's going to be after we've been through the peer review process. That's when we're going to look at like a learning management system to be able to host that content for the kids to be able to walk through it, and then some way for you to be able to see what they've created. So that's the ultimate goal and again, that was not at all on our radar when we started, and that's kind of why our timeline is what it is now. And it's not fully through the peer review process and all of that yet, because we changed, because again, when we started this and ordered all the supplies and started getting the group together in January, February, we thought this was something we were going to be doing in person with kids. Nothing else was on our radar. So we've had to kind of shift that, but I think I think ultimately it's something that's very, very, going to be very beneficial for us, and I think it'd be beneficial for you. One other note before I'm going to show you a sample of one of the activity sheets and kind of how they work in general. But the Microsoft Make Code that we've talked about, it's just a website. You don't have to download the program on your computer. It's just a website that you go to, and it's in each one of the activity sheets, the link to it. It has a really awesome simulator, microbit simulator. So you're going to be working with the simulator today. That's what you're going to be doing as you walk through one of these activities. So all 7 of these activities can be completed with the simulator and Make Code. So you can make your microbit in the simulator. You can make it scroll text. You can make it read a temperature, although you have to input the temperature. You can give it you can program the buttons. You can do all of that in the simulator. Now, if that's the only thing the kids ever get to do, is just work on the simulator and not actually have a microbit, it's not going to be quite as neat. However, if you're thinking, we've got 6 weeks here where we're not going to be able to see the kids in person, but then after that we think we are, it might be this might be something you could do virtually to get the kids, kind of let them learn the basics, and then once they're in person working with the microbits, it could be a little bit different. So I'm just going to show you one of these sheets, and then I'm going to turn it over to David, and David's going to actually walk you through one of them. So let me pull that up and share my screen again. All right, so you should be able to see the activity sheet now. This is activity 2, the buttons, how to program the buttons. So at the top, we have just a little description of each activity. So this one it says we're going to do the buttons and a little introduction. So this introduction is I have them think about, and this is something that the facilitator could read word for word, something that will be on the videos, or just something to help the facilitator understand. So think of all the buttons that are around you. You got buttons on every electronic device. Of course, not the buttons on your clothes, but the buttons that, buttons on the TV, buttons on a remote control, buttons on your washing machine, whatever it is. You got buttons all around you. Why do those work? Why does the TV come on when I press the power button? Why does it change the channel when I press the channel? How is that different than the power button? And basically, they're all programmed. They all have some sort of program, and that's what we're going to do in the microbit. So the materials is just the device and the microbit or the simulator, and then we actually walk you through step by step. So I'm not going to go through all the steps. Just see here that we do have screenshots built in to be able to help point you in the direction that you need to go. So even down to dragging it out from showing where to drag the blocks, where you find everything, all the different codes that you're going to need. So we walk you through it. So that's an example of one. That's a short one. This is activity 2. So really simple. A couple of them are a little longer. You can probably finish all of these individually within about a half an hour. You might, depending on the capabilities of your group, you might be able to finish the first 2 activities within a half an hour, and then a half an hour for the rest of them. Again, that depends on the group. And the target with this, the target is probably late elementary up through middle school. So probably starting in about 3rd grade, you could do this. And about 3rd grade, this would be pretty sufficient for them. Once you get up to like 6th, 7th, 8th grade, this would be a really good introduction, but you're going to want to go deeper probably than these 7 activities by the time you're done. So this is a great place to start, but you're probably going to want to go a little bit deeper than that. So with that said, I will turn the presentation over to David, and David's going to walk you through completing at least one of these activities.
All right, so as we get screens shared here, the first thing that we're going to talk about is the buttons, and that's going to be the first activity. And so in the chat, I dropped in the URL for the make code editor simulator. And so if you will go ahead, what I'd recommend is maybe doing a double screen so you can see what I have done, and then have the editor opened up. And so when you go to your make code URL, you're going to come into a project area. And so you're going to click on this new project is where you want to go. And so just want to make sure if you can give me a thumbs up in the window, and Barbie, if you can watch that to make sure that folks are okay and ready to proceed before we get in there. And so folks give me a thumbs up and we can know we can proceed. And so what we're going to do is you're going to click on a new project, and you're going to title it whatever you'd like. I like to use test just as a guide that we can kind of know where I'm working on. And so it's going to open it up, and what you're going to see when it opens up is that you're going to see the simulator is going to be up in your right-hand corner or left-hand corner of your screen. And then you're going to have this area, this menu area is your different commands. that you have. And then you have two different, this is kind of your programming or work area. And so that gives you a little bit oriented. So the first thing we're going to do is we want to use the buttons. And so our buttons are on the front of our microbit. And so you can see this in the simulator. We want to work with those buttons. And so there's two different things. On start means that when the microbit starts up or you download the program, this is the first thing that it's going to do. And I always put a very simple graphic in here. And so this is going to show an icon on the front of our 25 LEDs that we have in the front. And so when it starts up, that's going to show that heart icon. So that lets me know that that program is running and is working and in which program. And I periodically change that icon with a new program so that I know that it's actually downloaded correctly. That's a quick way you can test that. So the next thing we're going to use is an input. And so inputs are kind of think about things that information that the microbit receives. And then when it receives that information, you're going to then program it to react a certain way. So this is real simple. You're going to click on input, and then the first command in the input is on button A pressed, and you're going to drag this into this work area. And so what we have now is when button A is pressed, and so this little box right here can change A, B, or both of them. We want to do something, and so you're going to put a command inside of that. And so we're going to go real simple. We're going to go back to our basics, and we're going to go to an icon, and we're going to drag that into that area. Now you notice how it changed yellow and what forth, and it kind of clicked in. You heard kind of a click, and that's one thing you're going to notice. If you notice that, that's going to drop right in there. And so we're doing that block-based coding right now. I want to change my icon, and so you can change it to be whatever you want to. I'm going to use the check mark on the letter A. And so what that's going to do is it's going to tell the microbit when the A button is pressed, it's going to produce a checkbox. And so we're going to come over here and hit refresh. And the great thing about the simulator is it'll actually simulate the program that you've coded in there. And so we can actually go up here and click the A button with our mouse, and you can see it works as a check mark. I've also downloaded onto my microbit. And so you can see my camera here, get it right about the right place. If I press this A button, it's going to show a check mark as well. And so this is the physical component. And so that's something really important that they could download that program. And to download it, you simply click download on a computer. I'll just show you the process for this one. You're going to click download, and it's going to bring it up as a file. You're going to save that file onto your drive, just like you would download a picture from your computer and transfer it to a camera. You're going to save that, and that will then you can transfer that to your microbit and it'll run. I've already done that so that I can, for the purpose of teaching. Now we've got another button on there, so I'm going to put the B button on there as well. And so to do that, we're going to take the another on button, and we're going to change this to our A button to B. So we simply just change that, and then we're going to add a different graphic this time. And so I'm going to put in a different type of show icon. And so let's just make this maybe, let's do a smiley face. And so what it's going to do is going to show a smiley face whenever you hit the B button. You can always hit this little kind of refresh on the simulator, make sure it's ready to run. A button, still the check mark. B button is now the smiley face. So that's an easy way to just a simple way to use the buttons to program. Those buttons can be used for many different keys. This is just one thing. If you notice the lines on the 0, the 1, the 2, etc., you can actually connect different things to that, like a sound, a little speaker, or a buzzer, or even a servo motor. And so when you hit that A button, you have it maybe run. You can program those things to do that underneath each one of those items. So I want to first pause here and see if how everybody did. Were we able to successfully program the microbit in the simulator, thumbs up, or what forth to and see if there's any questions at this point before we go on to the next one. All right.
Hey, David, before you move on to the next one, will you go ahead and click on JavaScript there just to
Yeah, absolutely.
show them the difference there?
Yeah, so as Philip was talking about the text-based, you can actually program this in a text-based coding as well. And so even though you drop the pictures in, this will generate JavaScript for this particular code. So let me move some stuff around my screen just a little bit to get it out of the way. And so here's the actual code, Java code, that you have in there. And so you notice that the icon already has a preset name and what forth, as happy or heart. And so let's just say that I wanted to change, just so you could see. The B function is to show happy icon. And so I'm going to actually change that by copying the heart out of there. And I'm just going to rename this to heart. And so just to kind of show you, you can edit in both text. And so if I run the simulator, it will, let me hit refresh here. And if I hit that B button, it still produces heart. Let me just show, to make you show that. And so, and that's the same way you can do that. And also, along with that, it has your Python code. And so for those, if you want to go farther into programming, learning that text base, to give it a second there, it actually put it into the Python language. And so this is Python script. You can see it's a little bit different in how the notation is, but it allows folks to see. And you can convert right back to the block-based, and it'll generate back. And so that's a great way to be able to show block-based versus the text-based, and two different types of text-based. So want to check and see if anybody has any questions so far. Barbie, anything in the chat?
So I asked, did anyone who tried it have success? And Leah said no. So I don't know if there's something that we want to walk back through.
Yeah, we've got a
Anybody
little
can
bit.
unmute and ask a question at this point.
Yeah, we got a little time, so I'll show the other one before we get too close. But if you want to ask a question, let us please ask.
And the button piece was one of the very first things. I actually, in the lessons when we were building them, the introductions and the buttons were my piece. And it was huge for me when I learned how to do this. The heart worked good.
Okay, and so one thing I'm going to share with you is I'm going to share project. If you notice up here under share project test, you might want to actually name that something different. But you can actually publish this project. So I can publish this within my results. And so if you wanted to see the code, I can actually drop this in. And this is a great way to have your kids, if they're using the simulator, to drop your code in. You can share what they've done. And so if you click on that, you're going to actually be able to see the code that I have created and what forth. And so that just kind of gives you another way, as you're facilitating this and teaching this, this is a way that you can, even online, be able to see the code that the young people are working with. And so that's one way to do that.
And we were able to test that this summer with a camping program. And we had, this was that younger age population that Philip was talking about. We had quite a few 9, 10 to 12-year-olds, and they were sharing their code that they created so that we could see it. So they are used to, they're doing well with it virtually.
So was it Leah that wanted, that was having trouble?
She got the heart to work.
Okay. Well, Leah, if you want to share your code just like I showed, again, that's going up to share, and you're going to just name that. You're going to hit publish the project, and you could drop your own code in the chat, and we can even take a look at it from here. And so if that's something you like to do. I'm going to go ahead and move on for a quick second to our next activity, which is scrolling text. And I think that a lot of folks like this. And so you may ask, how did I get a new screen? Well, if you're in this, you can now get a new screen really easy by dropping this stuff over into the menu area, and it deletes basically deletes itself. And so I'm going to kind of start a new project looking at this. I'm going to change my icon. I'm going to go with the this little icon right here. And then for the scrolling text, what we're going to do is we're going to scroll a message across this LED. And so we're going to use our basic command, and we're going to say show string. And so what that means is it's going to show a string of commands to go. And so right now it's preset to hello. And so let's just take a look and see if that works. This is a real simple way to do it. And so I'm going to hit refresh. Obviously, I've got my, and then it's scrolling hello across the screen right now, and with an exclamation point. Now you can absolutely change this. Change this code, what you say. You can say, how are you? And put a question mark. And once you change that, you can, you'll see that it'll scroll. Let me refresh that. Shows my icon, and then it's how are you? We'll be scrolling across the LED. And so this will work very similar. And you can change that to whatever. And so that's an easy way. I'll go ahead and share this code. I'll need to rename it to, let's go V2, just so we have a different publication here. And I'll share that code if somebody wants to grab it and in the chat so people can take a look. So it's really a simple starting to just try it and learn how to use the coding. And you can also, I will bring up just so we can see. So there's the coding that I had. I will bring up the look for JavaScript. And so you can see it's going to say the duck and how are you. Now, also along with this, I'm going to give you one more function and go back to block coding. I want maybe before that, this is not really in the lesson of scrolling text, but this is something I want to show you. It's kind of associated with. You can design your own, if say we want to create an arrow and for something. So you can actually create your own design that shows up. Now, I always put a little pause in here. So this is a different command. It's a pause in between the two strings so that you actually get it to show on the screen. And so I'm going to change this to 1 second, or let's go 2 seconds. And so what's going to happen if you look at the simulator, you're going to see the kind of the up arrow, and then it scrolls. How are you? And so you can see it waits about 2 seconds before it happens. Now we're in the for whatever block. This means it'll happen over and over and over. Anything you put in this for whatever area will occur over and over after it starts up. So that kind of concludes what I wanted to show, and just some of the lessons. And each of our lessons has a little deeper activity with it after you get through that initial skill or activity. We're just trying to build understanding of how to use the microbit in this. So we'll take any questions that from the group, and let me give it back to you, Philip.
Yeah, I know we kind of move fast today. That's the nature of these things, and the brief period of time we have to share. But remember that we have activity sheets, and then we're in the process of creating videos as well. The hope with the video is that you could even just show the video to the children and let them work directly from that, or it's a way for you to be able to learn. So we do have more resources. It can seem a little bit, if you're starting from no experience, it can seem a little bit overwhelming, but it's really it's really, once you get into it, you learn, and you don't need a lot of experience or expertise. So we will open up the questions in just a second. I'm going to share the screen. Barbie put the link to the survey to evaluate this session. She put that in the chat, so we'd appreciate if you could fill that out. I'll share the screen as well. You've got a QR code here if you'd rather go directly with the QR code. And then Barbie, do you have the link for the email addresses, to collect their email addresses? So Barbie's going to drop another link in there. If you wouldn't mind putting your email address in there, we'll send you the links from today. We'll send you the link to the Google Drive, and we'll send you kind of just notifications, keep you updated as we continue to add materials, as they go through the internal peer review process, as we finish the videos. All of that, we'll be able to keep in contact with you to send. I promise you, we won't overwhelm you with emails, and we won't send them every day or every week or anything like that, but just as we have some updates to be able to provide you with these activities and curricula. So we've got about 2 to 3 minutes remaining on the session. So again, if you could do the survey and then click on, it's another Qualtrics link to just give us your email address, that would be greatly appreciated. And then we'll take any questions that you have.
So there is a question in the chat that these sessions will be available for the next 2 weeks. How will I be able to access them to show them to my staff?
Access what?
The session?
This session or the
materials?
The materials? Yeah, the materials will be permanent. So we've got that Google Drive folder, and I think we have, it's the 15th, October 15th is our deadline to finish, any little updates we have, and then finish the videos as well. So we'll have the videos to